So let's look at a first order example. I'll give you, on your second assignment in week 7, I'll give you some of these to do just because they're not as computationally involved, and it still shows that you're learning to use the method. So the point is you can apply the Laplace transform method to any order equation because we reduce all the derivatives get reduced by the derivative formula so that our new equation only has an unknown, which is the Laplace transform of our solution. And then we solve that equation algebraically for capital X of S, and then we just have to compute the inverse Laplace transform of whatever we see for that. So we apply the Laplace transform. The first term, we use the derivative formula. Laplace transform of a first derivative is just S times the Laplace transform minus X of 0. So that's 0 in our case. That's our initial condition. The second term is just the Laplace transform of X, which we're denoting again by capital X of S. And the Laplace transform of sine t is, we have that formula as well. So it's 1 over S squared plus 1. Since x of 0 is 0, this simplifies. Solve for x of s, we just get a product of two functions, 1 over s plus 1 and 1 over s squared plus 1. So x of t is just the inverse Laplace transform of that product, and that's our convolution formula that we use. So the inverse Laplace transform of 1 over s plus 1 is e to the negative t times t. That comes from our power exponential formula for the Laplace transform. And then we know that the 1 over s squared plus 1 corresponds to the Laplace transform of sine of t. So we integrate from 0 to t. I'm sorry, I misspoke. 1 over s plus 1 is just e to the minus t for its is the Laplace transform of e to the minus t, because it's 1 over s plus 1 to the first power. Because 1 over s is the Laplace transform of 1, so when I shift it by a negative 1, because s plus 1 is really s minus 1, we get an e to the minus t. So how do we convolve that? We integrate from 0 to t, we take e to the minus t, and then we replace the t by t minus z. And then our second function is the sine of t. We just write sine of z, or whatever letter you want to use. If you don't want to use z, you can use something else. And just remember that t is just a number. It's a fixed value in this integral, so you can integrate it. It's basically an integration by parts problem. Or you can just plug it into something like Maple. But the point is, the setting it up of the convolution integral is what you need. And then the result is just integrating. And you get a function of t. And you can see that the solution is the solution. Now, if you were to do this by hand, you're basically integrating an exponential function times a sine function. And the idea there is to integrate by parts twice, because when you do that, you always have the exponential staying in the integral. You might pick up some minus sign or something like that when you differentiate or integrate. And then by doing it twice, you're converting the sine to a cosine and back to a sine again, but you got to keep track of all the details. So what you're going to get is this integral is going to be equal to some term plus some multiple of this integral again. You just solve that equation for this integral, and what you get is what you see on the right side. So try to do that on your own. It's good calc practice anyways. But this is the answer, so see if you can get it.